Okay, this is chapter 7, section 2. We're going to talk about linear systems in 3 variables in this one. Solutions of systems with 3 variables with linear equations have 3 possible solutions. Okay, they have one solution if they if they when they have 3 variables, instead of acting like lines that intersect, they act like planes that intersect. Okay, so the planes can intersect in one place here if we get one solution. The planes can intersect and form a line. You get infinitely many solutions, or all 3 planes can be the same plane if the lines are just multiples or something of each other. So we're just going to do the first 2 where we have one solution, how to figure that out, and how to figure out infinitely many solutions if the planes intersect like this, where they form a line. Okay, so a typical problem looks like this. You have these 3 equations and 3 unknowns. Okay, that's pretty typical for these kinds of problems. Okay, so what we want to look for when we do this is how to eliminate some of the variables. Okay, right away in this equation 2 and 3, we can see we have a negative z and a plus z. So we're probably going to want to add these 2 equations together and eliminate that z from these 2 equations. Okay, so that's what we did here. We added these 2 equations together and got 3x plus 2y equals 4. Okay, so just added those 2 together. Okay, so then once we do that, we want to look for another way to eliminate equations. So we already eliminated the z from equations 2 and 3, so we probably want to go ahead and eliminate the z from 1 and 2. And we can do that if we multiply equation 2 by 6. Okay, so we multiply the equation 2 by 6, and we get 12x plus 6y minus 6z. That's what equals 12 here. We add it to the first one, and the z goes away, and we get 15x plus 15y equals 15. Okay, so that's adding these 2 equations together, but we multiplied the second one by 6. Okay, so that gives us 2 equations where we have only have x and y. So now we're down to 2 equations with 2 variables. Okay, so we want to eliminate, you can eliminate either one of these. We're just going to eliminate the x. So eliminate the x, right? Has a 3 and this has a 15. So to eliminate the x, we are going to multiply this equation 4 by negative 5. Then we're going to add them together. That's usually the easiest way to do it, is multiply by whatever the opposite is, and then add the 2 equations together. You make less mistakes when you do it that way instead of multiplying it by 5 and then subtracting. You could do it that way, but make less mistakes when you multiply by the opposite, then add the 2 equations together. Okay, so what's happening over here. We multiplied equation 4 by negative 5. We got these coefficients. We add them together. We got 5y equals negative 5, so y equals negative 1. Okay, so we figured out what y was. It has to be negative 1. Okay, so then we go back to one of the other equations we had and substitute y equals negative 1 there and figured out that x equals 2, right? Negative 2, add the 2, makes 6. 6 divided by 3 is 2. Okay, so we've got y is negative 1, x is 2. Then we can pick out any of the other equations we want and just put the 2 for the x, the negative 1 for the y, and figure out what z has to be. So z has to be 1 when we do that. And that's our solution to that original problem where we had the 3 equations and the 3 unknowns. So you have to eliminate one of the variables, then get 2 equations with 2 unknowns, then eliminate those, solve it like we normally do with the 2 equations, 2 unknowns, solve it that way. So you have 3 equations, 3 unknowns, you're going to get a unique solution set. If you have 2 equations and 3 unknowns, you're going to get an infinitely number of solutions that'll work for this one. Okay, so just know that going in, that there's no way you're going to get if you have this setup, you're going to get, this is like solution. Well, at the beginning of the show, we had, this is where the 3 planes intersect and form a line. That's what happens here. Okay, So to eliminate some of the variables, and it doesn't matter which one you choose, but choose one. We chose to eliminate the x here. So we multiplied everything by -3, added everything together, and got this equation down here at the bottom. -7y minus 7z equals -21. Okay, so it's multiplying the top one by 3 by -3 and adding the top 1 and 2 together. Okay, so this is the first equation. Then we just solve for, we have two unknowns here. So we solve for one of them, and it doesn't matter which one. In this case, we solve for z. So z equals -y plus 3. Okay, so we've solved for z in terms of y. Okay, so in the other equation, now we need to figure out what z is in terms of x. Okay, so if you understand what I mean by that, I mean that I have to put z equals something, plus x plus or minus something. Okay, we've got z equals y plus something. Now I need to solve it for z equals x or plus something or minus something. Okay, so yeah, so we got, we just solve for z. I don't know, this don't worry about that down at the bottom. Okay, so we took the other equation here we solved for x, right? We get x equals 2y, -2y minus z plus 4. Okay, so we just took that first equation we had, and it had, because it had x, no coefficient by x, it was easy to get x by itself. Then we substitute in for the y variable, we put in the z. Let's put in 3 minus z, because that's what we solved on the other one. We got that y equaled 3 minus z. So now we have all these z's on this side. We multiply by 2 here, combine like terms, and we get x equals z minus 2. Okay, so now what we have is a solution that is written like this. So instead of writing x, y, and z, instead of writing, oops, I can't write. Oh well, let me go back. I thought I could write. Can't seem to write on this one. Okay, so instead of writing x, y, and z, we would put in these substitutions for it. Okay, so x equals z minus 2, y equals z minus 3, and z would just be what it is. And then for any value of z, we can figure out what x and y have to be. If z equals 1, then y equals 2. And if z equals 1, then x equals -1. So that gives us a solution set of -1, 2, and 1. And we could have solved this for any of the other variables here. We could have had, the x by itself, and then, x something here, and a y, and z some term. We could have solved for these variables. We could have solved it in terms of x. We could have solved it in terms of y. So it wouldn't have mattered. It's just whatever is easiest to do, and you'll get the same solution sets no matter which way you do it. Okay. The other thing we do with these systems of solutions is these somewhat practical ways to these problems where you have what's the best, how many units of each ingredient should be made. The feed that contains, you want it to be some amount, 22 units of protein, 28 units of fat, and 18 units of fiber. Okay, this is what our total we want it to be. This is our ingredients we have and the protein, fat, and fiber content of each one. So what would be the best way to mix it or to get that? So we have three variables, three equations here, three unknowns. Okay, so we're just going to get one solution to this one. Okay, so we set it up like this. This is my x, how much of the corn is going to be the x, the y is going to be the soybeans, the cottonseed is going to be the z. Okay, so that's the x, y, and z has to have 22 protein. The x, y, and z has to have fat, that. So they just multiplied everything by 100 to get rid of the decimals. And then we solved it similarly to the way we did the first problem. So you're going to eliminate a couple of these things. Maybe you can subtract this one, you know, subtract this one from this one, and get those two, eliminate the y, maybe would be what I would do on this one, and then go on from there. So this is how you would set it up. You have, you know, the x variable represented the corn, the y variable represented the soybeans, and the z variable represented the cottonseed. So it's just, you know, it's just another way of setting up these equations, and usually have it like this with three equations, three unknowns, and they're trying to get you to solve for one, you know, there's going to be one solution to it. So most of the time they just do it like this. They don't have any, um, it's not that hard. Instead of giving the equation down here like this, they just make you work a little bit for it. Okay, the last one we're going to go over is find the equation of the parabola with the vertical axis that passes through these points. Okay, so these are my x's. I got three x's, three y's, and I have to figure out what, you know, equation for a parabola that goes to those points. So how are we going to do that? So we're going to substitute each ordered pair into our parabolic equation, you know, the quadratic equation. Okay, so we do that. We get the y value here has to equal, you know, this would be x squared. This 4 here is 2 squared times a value. Then 2 times b, and then plus c. Okay, that's we get from this first point. When x equals 2, y has to equal 4. Okay, in the second equation, we put y equals 1 over here, and then negative 1 squared is just 1. And then negative 1 for b value gives me negative b. And then c, we don't put anything for c in any of these equations because we don't know what that is. So the same thing here with negative 2. Negative 2 squared is 4. Then minus, when b is negative 2, we get minus 2b, and then plus c. Okay, so that's the trick to it, is to just put an a and a b and a c here. So we have three variables, three unknowns. Okay, we're going to figure out what the a, b, and c is on this quadratic equation. You know, the equation for a parabola is what it is. So eliminate c using equations 1 and 2. So we're going to, so we get this one here, we multiply everything by negative 1, add them together, we eliminate the c. Okay, so we get 3 equals 3a plus 3b. Then we eliminate c again using these two equations, right? We're just going to multiply the bottom equation by negative 1, change the sign on the c, add them together, and we get negative 4 equals 3a plus b. Okay, so now we have two equations, two unknowns. Then we're going to eliminate the a value, right? We have 3a, negative 3a, positive 3a, so it makes sense to eliminate the a value. With negative, we're just going to add these two equations together. Okay, so we add these two equations together. The negative 1 equals 4b, so b equals 1/4. Okay, so we're almost there. And then find a by substituting one of the other equations here, that 1 equals a plus b. So where did they get that? They got that from this equation here. They just divided everything by 3 and got 1 equals a plus b. Okay, so that's where they did that substitution in there. And so they put in b is 1, so a is negative 3. Okay, so find c by substituting into the other equation we know. So we know that it's a minus b minus c. Where did they get that? They got that from, where did they get that from? This one right here, the second one. So they got 1 equals this minus that minus that. So now we know what a is, now we know what b is, and then we could, that's the easiest one to substitute it in. So we just would do that. Okay, we got C equals 1/2. So now we have our A is 5/4, our B is 1/4, C is 1/2. Okay, we put it in their equation, so we get this equation for the parabola. Y equals 5/4 x squared minus 1/4 x minus 1/2 is the equation of the parabola that goes through that point. Okay, so that's the end of the show. So answer the questions on the form below, and I'll see you